Hi there, my name is Wes Johnson, and this is my final presentation for Biology 3550 in regards to sequence 10. Here we have the nucleotide and amino acid percent identities in regards to sequence 10 from the different BLAST analyses, including BLAST-N, which is involved with nucleotides, BLAST-X, which is involved, and BLAST-P, both of which are involved with amino acids. And here are my findings from the ORF. Here are my results, I should say, from my ORF finder. And here we can see that the best result is the ORF1, mainly because it's the most prominent and it is making it the better translation for my amino acid sequence. Then I ran the translated amino acid sequence from sequence 10 through the conserved domain database, and I came up with a big old goose egg. It didn't come up with anything, which I guess that's okay, but still. Then I ran my translated amino acid sequence from sequence 10 through signal P, and it didn't show anything. No secretion signals or any of the sort. Then I ran the translated amino acid sequence from sequence 10 through TMHMM, and the results show that there is no transmembrane domains. You can kind of see something a little right here around the 200 mark, but if you look on the probability scale, it's highly unlikely that it actually exists. So we're just going to assume that there's no transmembrane domains at all. And here I then ran my amino acid sequence through the FIRE program and got a predicted 3D model of sequence 10. Look at that cute little guy. Just so cute. Then I pretty much ran the translated amino acid sequence and all of the different related sequences from my BLAST-P analysis, well, BLAST-P and BLAST-X analysis, and I was able to create a cladogram using NG phylogeny. Now, from this, we can see that our translated sequence of sequence 10 is very closely related to this one right here, the YP_009237270_1, the pupative nucleocapsid protein, which is interesting because if we look in our BLAST analysis, we see that this specific one right here showed 100% related, like it was 100% related to our sequence in question. Keep that in mind, because that's what our sequence is. Our sequence is the pupative nucleocapsid protein found in the Fig mosaic virus. Now, its main function is to aid the virus in intercellular transportation. The way it does this is through congregating in the cytoplasm near the exterior membrane of the endoplasmic reticulum, pretty much creating a protective bubble around it, attaching it to the endoplasmic reticulum, and then it's able to use the functions of the ER, or endoplasmic reticulum, for intercellular transportation. Super cool. And I found all this information from this source right here that was actually conveniently done in regards to this specific protein from the Fig mosaic virus. It's a super interesting read. Highly encourage you, if you have the time and you want to know more about this specific virus and the specific protein and how it helps the virus, I'd say give it a read. But thank you for watching my presentation.